Okay, it doesn't allow me to share. What's wrong? Okay. I had to reconnect because it didn't allow me to share. Okay. The purpose of the experiment today. Megan, Tiziana, Juan, Saima, can one of you tell me what's the purpose of today's experiment? What are we trying to do today? Performing the experiment 8, what were you trying to do? Okay. Let me know if you can hear me because it kind of, I had to reconnect. I just want to make sure everything is working. Can you hear me? Yes? Okay, that's good. And what's the purpose of the experiment? What are we trying to do today? Okay, the next 4 people, Robert, Natalie, Elaine.
Yeah, I'm just going to tell you that this is going to be really hard for a lot of us because a lot of us have not even touched thermodynamics in lecture. We haven't even looked at it.
Really?
Yes, not even
Thermodynamics comes right after the...
Not touched thermodynamics at all.
Yeah, most of our classes are a little farther behind than this.
So these last two, so experiment 7 and 8, just so you know, for us, were extremely hard, extremely tedious, and extremely time consuming. Even for those people who, you know, chemistry is natural for, it was really hard to do.
Okay, so thermodynamic is not covered yet in lecture for any of you?
No.
No? Okay. So you read the first page of this experiment. What's the purpose of the experiment? What are we trying to do? I'm not asking for what the formula is, what we are trying to do today. Yes, Janelle.
To understand the relationship between delta G, delta H, delta S, and KSP and how they may be determined experimentally, and to explore the relationship between delta G and KSP and the temperature effect on the two.
Okay, anyone else? The purpose for today's experiment? Based on the first page of lab manual? What we are trying to do today?
We're trying to figure out how the energy is converted from one to another. Everything consists of energy, just how it comes in and how it goes, leaves the system. So I would assume that's what we're doing.
Okay, anybody else? Based on the first page of the lab manual, what are we trying to do? What's the purpose of today's experiment? We have some responses, which are good. Anybody else? What we are trying to do today? And I did not say if the answers that they were out, they were correct or incorrect. I'm sure you looked at the first page of the experiment. From the lab manual, right? What's the purpose of today's experiment? What we are trying to do? To see how energy is converted? No. Conversion of the energy, that is something that we don't study in this experiment. Of course, there is a... Yes, Nia?
To understand how Gibbs free energy, enthalpy, entropy, and the solubility constant are related through through the experiments that we're gonna do with, like, what was it? Calcium hydroxide and such.
Very good, very good. Okay, when you talk about thermodynamic, the thermodynamic values, okay, there are three values that you should be concerned about. One is delta H, which is the energy of the reaction or enthalpy of the reaction. Basically, if the reaction is exothermic, the value for delta H is going to be negative. For endothermic reaction is positive. But what is delta H? Is the amount of the heat that is either needed or released when the reactant is converted to product. So what we are trying to find today is to find the value, the thermodynamic value for a single reaction. We are not trying to determine the relationship. The relationship has been discovered by someone else already. So we are going to study and we are trying to find the thermodynamic values. That means delta H value. And if it has not been covered before, you can go back and watch this video, but it would be more healthier and helpful if you take notes so you know what needs to be done. So when you are on your own, then you can at least, follow your notes, or don't depend on later on, because later on when you watch the video, if there's something you don't understand, I'm not there to explain again. And I'm not trying to teach you thermodynamic. I'm sure it's going to take a few hours to teach at least. But based on today's experiment, I'm just defining what the terms are and what we are going to do. So for you to be able to perform the calculation in your data sheet, it's to, it's better to take notes and just understand what each value is at least. So the value for delta H is going to be calculated, and I will tell you in a few minutes how. So it's the amount of the heat that is going to be either released or absorbed. How do we know it's released? If the value becomes negative, that means it's released. If the value is positive, is absorbed. The value for delta S, that's another thermodynamic value. So for a reaction, when we study thermodynamic of reaction, we want to be able to determine what is delta S. Delta S is degree of disorder. So when your reaction goes from reactant to product, sometimes let's say even if it's for like physical change, if solid goes to gas or solid goes to liquid, what happens to degree of disorder? Would it increase or decrease? The degree of disorder is going to increase Basically, change in temperature is going to make also the degree of disorder increase. So change in phase, if it's going from solid to liquid to gas, because there's like more random movement, meaning that degree of disorder has increased. The value for delta S, if it's negative, or that means the product have more, they are more ordered, they have lower degree of disorder, that's not good for a reaction. A positive delta S, it means that the reaction is actually helping the reaction to happen. A positive delta S is good, a negative delta H is good. Negative delta H, that means energy is being released, so your reaction doesn't require heat. A positive delta S also means that degree of disorder is increasing on the product side. That means that the reaction is going to happen most likely spontaneously. But the single factor that would tell us if the reaction is going to be spontaneous or not is the value for delta G. And the highlighted formula can be used to calculate value for delta G if you had delta H and if you had delta S at a given temperature. The temperature must be in Kelvin. If the value for delta G is negative, that means your reaction is spontaneous. If it's positive, is non-spontaneous. So for a single reaction given in this experiment, we're trying to find the value for delta G, delta H, and delta S. But we are not given any of this information. If we have two of them, we can calculate the other one. We don't have any of those. So we're trying to do like titration, and using the titration and finding the solubility factor, we are going to find the values for delta G, delta H, and delta S. So these are some explanation. Also, you can read it based on what I told you. If you have any questions, you can ask me again. When we do titration today, we are trying to find out what's the concentration of hydroxide ion. Okay, for concentration of hydroxide ion, let me just do something so I can get the. If I can turn on my surface, it would be easier for me to write on. Okay, hopefully it comes up. Okay, when we do titration today, we are going to find concentration of hydroxide ion. And we are going to use that in two different temperatures. We find the concentration of hydroxide ion. And when we have that part, I'm sure it's been covered already in 1045 lab and lecture. And you know how to do the titration and calculate concentration of the hydroxide ion. If you have concentration of hydroxide ion based on this equation on page 110, can you tell me how would you find concentration of calcium ion? What's the relationship between concentration of hydroxide ion and concentration of the calcium ion?
Wouldn't it be 1/2 of the hydroxide?
Yes, very good. So we find the concentration of hydroxide using titration. Then we will find the concentration of calcium by dividing concentration of hydroxide by 2. You get the concentration for calcium ion. If you have concentration for both of them, has equilibrium been covered? Equilibrium has been covered in lecture, right? Okay, equilibrium for other reaction. The K value, KSP value, equilibrium expression is concentration of product over concentration of reactant raised to the power of coefficient. Solids and liquids are not allowed. You remember that expression, right? Concentration of product over concentration of reactant. Solids and liquids are not allowed, and each one is raised to the power of coefficient. So for KSP, when you are dealing with solubility, your reactant is solid, and since the reactant is solid, is not going to appear in the equilibrium expression. So that is called KSP, or the ion product. So basically it's saying if calcium hydroxide is dissolved, how much calcium ion and hydroxide ion is going to be produced. And if you put this in formula, you can calculate KSP. So based on that, we can calculate KSP at one temperature. And if you increase the temperature, you can calculate, you can do titration at the high temperature, and you find the KSP value at secondary temperature, at a high temperature and a low temperature. When you have the values for KSP at two different temperatures, then you can then you can get the values for KSP. Then you are using this formula right here, this formula. So at this point, you're just going to have to just copy the formula and use it until it's covered in lecture. If you have KSP1, how do you find the value for KSP1? What does KSP1 means? Can anyone just emphasize it? Can you tell me what does it mean? The solubility constant at temperature 1, right? Just be a little bit more specific, so it's good. Is the solubility constant at temperature 1, and what is KSP2? What would be the KSP2? Solubility constant at temperature 2. The delta H is going to be the same. If the temperature is high or low, the delta H value is going to be the same. So we have that you are going to use that equation. So what is unknown in this equation? In Ln KSP1 over KSP2 equals delta H over R, 1 over T2 minus 1 over R2. What is unknown?
Is it the delta H?
Very good. So the only part that is not there is the delta H. So you can calculate the delta H. So step 1, you do titration at temperature 1. And from the titration, you find concentration of hydroxide ion, you find concentration of calcium ion, and then you find KSP at temperature 1. From titration at high temperature, you find the KSP value for high temperature. Then you plug in this number, the numbers here, and just make sure that the temperature is in Kelvin. The value for R is a constant value is given. So you have the temperature 1, temperature 2. You have KSP at temperature 1 and temperature 2. Since everything is known, using the math problem, you are going to find the, I'm sorry, find the value for delta H. So the goal is today to find the value for delta H, delta G, and delta S. There's another equation that you can use, delta G equals RTL and KSP. This one, please make note, this one could be either KSP1 or KSP2. You just use either one of them. Is going to, the reason I say use either one of them, if you use the KSP1, use here the T1. If you use KSP2, you would use the T2 also. So it's the corresponding temperature. You are going to calculate the value for delta G. So far you have the value for delta H and delta G. What would be last step? What's missing? What else do you need to find out? Value for delta S. Okay, good. So how do we find the value for delta S? You're going to the delta H and delta S. After you calculate them, they don't depend on temperature, so you can use either one. So when you have the delta H and delta S, I'm sorry, you have the delta G and delta H, you have the temperature, you can find the value for delta S. So when you have the three values, delta S, delta G, and delta H, the thermodynamic concern is solved, or the problem is solved, because when you do study thermodynamic, all you have to do is just find the value for delta H, delta G, and delta S. When you learn about thermodynamic in lecture, this is not the only way to calculate the delta H and delta S and delta G. There are tables that you can use to find the H of the product minus H of the reactant. For those of you just maybe slightly have reviewed or you have seen it in lecture. And delta S could be S of the product minus S of the reactant. But in order to calculate in that way, we have to have those numbers, and those numbers are already recorded in the appendix of any general chemistry book. So that doesn't help us in the lab to do hands-on and experimentally find these values. So what we do in lab, I kind of twist this. I use the other relationship. We study the relationship between the delta G, delta H, and delta S. But at the same time, we are using our finding in the lab in order to do the calculation. Any questions about the purpose of the experiment and what we are trying to accomplish today? Questions?
Professor, there's going to be two delta G numbers for each reaction at different temperatures, correct? Or is it just one?
When you calculate the value for delta G, you take the corresponding temperature, okay?
Mm-hmm.
You're going to take the corresponding temperature. And the same delta G that you're finding in that temperature, you can use that, the same temperature, to find the value for delta S. The delta S, delta G, and delta S values, you will learn in lecture also that these are state functions. So it doesn't matter what route you go, and it's just one value given. What can change with the temperature is when you change the temperature, the value for K value, or equilibrium constant, changes with the change in temperature. But the thermodynamic values are going to be the same. So it doesn't matter which one you use. The only reason I said you have to be concerned about the temperature here, because the KSP has to be corresponding to the temperature that you calculate, that KSP value. So you could use either one, yes, at the high temperature or low temperature. You can use the delta G value. And one thing that you can try for this experiment, just to get that answer to yourself, when you find the KSP value, KSP1, use the KSP1 with T1, find the delta G, use the KSP2 and T2 and find the delta G. If the experiment doesn't have too much experimental error, both numbers should come up with the same delta G value. So the delta G value is not going to change.
Thank you.
You're welcome. Any questions? Did you get the purpose of the experiment and what we are trying to do today? Okay, perfect. I just want to make sure that you can use the formulas provided here to do the calculation for the experiment. And that's the purpose of the pre-lab discussions, actually, to make sure to answer your questions and to make sure that you know what we are trying to do. And I was planning to ask every questions from you guys. I guess I picked the wrong day because I haven't asked questions, a lot of questions. And sometimes when I don't ask questions for 2 weeks in a row, then it's human nature. I mean, some students, they study the experiment before coming to class and the procedure, I mean, and others, they wait until the class time. I wanted to make sure to give warning that this is supposed to be studied before the procedure, it's supposed to be, you know, studied before coming to class as well. But it's okay, since it's not covered in lecture already, I did explain what's the purpose and how we are going to approach it. But if you have any questions about the titration part. Calcium hydroxide is kind of exception, so do not be surprised when you increase the temperature, solubility should increase, right? Generally, solubility increases with temperature. In this case, for solubility of calcium hydroxide, when you increase the temperature, solubility is going to decrease. So when you see like we are using less of the acid or less of the titrant to find the concentration of hydroxide ion is at the high temperature, don't be surprised, because I've heard that from many, not just the students, from other people that, well, it doesn't make sense, something is wrong with the experiment. Then as soon as I asked them to look at the KSP value at different temperature for calcium hydroxide, higher temperature is supposed to give you lower value for KSP, for calcium hydroxide. So don't be surprised for that. Don't panic. Okay, last time, I think it was for this experiment? The measurement, after I post the measurements, then I actually watched the video. I watched and by just going back and forth a couple times, I was able to hear from the video also those data. So I'm not going to, just like last time, I'm not going to post them, because then some, I'm not saying all, the may not watch the video. I mean, just to see at least how the experiment is done, to learn about, if in case, you know, you had to do it, at least you see it. Blackboard Collaborate was discontinued. The use of Blackboard Collaborate was discontinued by the college, and since they wanted to free up some space, I guess, they deleted all the videos that I had in the Blackboard Collaborate. I was lucky that I downloaded some of the videos just the week before they deleted. So otherwise, we had no videos, and I had to go to the lab middle of the semester. I am going to, you know, to create new videos using different camera, but I used the Blackboard Collaborate last time, and now, I mean, you know, we lost them all, so we can't use them. I know. They promised that they will allow us to use it until May 10, and that's what we are using. We are still using Blackboard Collaborate. They just deleted their anything that was recorded before this semester. Unfortunately, middle of the semester, and that's not nice. So for data, if I'm going to watch the video, if there is anything that I cannot hear, then I will post that value only. But we are not going to. We are using Zoom after May. Zoom is used after May. Yes. but please, if you watch the video now with the YouTube, is easier to go, you know, back and forth and try to get the values in the caption of the video. Yes, but believe me, with the number of videos that I have, I can do that. I mean, if you cannot hear, I'm going to watch it. And if it's something that students cannot hear, because the purpose of the video is to make the students to watch, and that counts part of the class attendance, because the 3-hour lab, you only are here for half an hour, sometimes 45 minutes. And I don't want that, you know. So the second part of the attendance, it counts for like watching the video. So I want to make sure that students watch the video, they collect the data. And if there's value that I wrote down, I typed it in the chat area, but I didn't say it loud for you to get it, I will add those as a caption or as a comment to the video or announcement, whichever is going to be easier for me, I would do that. But if, you know, if I can hear, I would expect you also to hear and write it, please. Okay, any other concern or questions you might have for me? For this experiment or in general, do you have any questions, any concerns? The final exam, I do have like one announcement for the final exam that it says the type of questions that you have. And if that is, I'm going to review it again. So the final exam is going to have questions from pre-lab and data sheet. And that would be from the pre-lab that have been graded up to the point of the final exam. I make sure that those are all graded, so you know if your answer was correct or incorrect in the pre-lab. And some understanding, especially you get a lot of questions from experiment 1, which we spent like 4 weeks on it. You get a lot of questions from that. Very similar questions to pre-lab and post-lab questions that you have there. I only change the observation, and then I get the, and then other experiments, like today I was grading the Le Chatelier's principle or experiment 4. Some multiple choice, some free response is like half and half, at least half of it would be multiple choice. Like if you make any changes, would the reaction would go to the product or to the reactant site? I mean, questions like that. And for kinetic, you had, if you double the concentration, how would it change the rate? So these are questions that you learn in the pre-lab as well. So it's basically based on understanding of the experiment and similar questions to pre-lab and post-lab questions. Okay. Okay, if I tell you that the questions are very similar to the pre-lab, post-lab questions, then your pre-lab, post-lab questions are going to become your study guide. And you have access to them on the submission folder. You just click on your submissions and you view, and you could view the comments if there is any comments also for the wrong answers. But if I put them all in one document, no, I'm not going to put them all in one document as the study guide, because that's lengthy and it doesn't. Because if I do, I'm just going to copy all the pre-lab questions in one and then data sheet in another, or questions, extra questions, additional questions from data sheet in another document. That's, you already have them, and it makes sense for you to read experiment by experiment rather than me putting them all in one document. So it's going to be the same thing. As long as it makes sense. Thank you. Okay. Any other questions you might have for me? Yes, it uses not the lockdown browser, is the other one. Honor lock. Final dates. It's the week after experiment 9. So we're doing experiment 8 today. And today is what is today? Today is the today is the 30th. And then April 6th, we have the experiment 9, April 13. Okay. April 13 would be the final. Every department requires now to use using the honor lock, and if you had problem for the before, it should be resolved at this point. And I want to make sure that the exam is going to be during the class time, so it starts at 11 a.m.
And it's multiple choice, correct, through honor lock?
Half multiple choice, half free response.
The responses are going to be typed in, correct?
Yes.
So and calculations will not be done?
Even if the calculation is done, it would be like simple calculation to be able to type in.
Gotcha.
Yes. Saima is going to be the same day as your lab, Tuesday, 11 a.m. No notes. No notes. For the exam, no notes.
And it's just based off the experiments we've done. So do we study the experiments, or do we study, what do we?
You studied experiment in order to be able to answer those pre-lab and post-lab questions again.
Oh, okay.
Yes. The questions are very similar to pre-lab, post-lab questions. Yes, additional questions that you have on the post-lab, yes. The post-lab questions are pre-lab questions. Okay, and if you had more questions about the final, we can ask next week. We still have next week before the final. Okay. Questions for me? No questions? Megan? Tiziana?
Megan's here.
Yes. Juan? Juan, I think you joined like late, super late, or you had problem with your internet. What was the?
Yeah, I had issues, but I joined. I'm gonna watch.
Saima?
Professor Tiziana.
Yes, I got you. Robert, people who answered some questions and I do remember, I kind of don't wait for the response. I know they are here. Natalie? Elaine? Janelle? Caitlin? Isabella? Nia? Andre? Camilla? Kaylin? Jonica? Alex? Alex? Jonica? Jonica is absent. Okay, absent for Jonica. Crystal? Alana? Navid? Daniela? Luke? Naya?
Here.
Sabrina? And Joven. Naya, I didn't get response from you. Naya, are you here? Good, thank you. Okay. Any questions for me?
Yeah, I was just wondering, from all the pre-labs and labs we did, that's kind of like it's like a lot of information for us to retain for a lab, because normally labs are supposed to be like a hands-on from lecture, correct? So I mean, I think it's kind of like a little bit difficult to study for a lab that you're supposed to be doing in person. I mean, I know we're in tough times and everything, but um, I just maybe that's like a little bit excessive, don't you think?
For me, no. For me, it's very easy.
I mean, I know for you it was easy
I'm
because during
sorry.
your
Yeah,
times
that was
you were learning
okay.
all your information in person. But right now, because of our circumstances, we're learning a lab that was supposed to be done in
Okay.
person and hands-on. I mean, I'm not trying to complain, but like, you know, in the same time, it's hard for us too because half of the time we have to teach ourselves.
You can complain. Let me stop recording so we don't.